Hello, I'm Marina.
I'm Darlene.
I'm Chris.
I'm Audrey.
And I am Fatih.
Together, we are
Pentagrow.
In the power of 5,
We
Grow.
Sustainable
Solutions.
did you know that in 2024, Indonesia produced around 10.6 million rice husk waste, making Indonesia as the largest rice husk waste producers across ASEAN? What if I told you that this waste could actually be used to power clean energy transition instead of polluting the air?
with refill supercapacitor, we can turn agriculture waste into sustainable energy. Let's get into it.
Our project addresses two key sustainable development goals: sustainable cities and communities, as well as climate action.
So, the question remains, how can Southeast Asian cities grow greener, power faster, and cut emissions all at once? Our answer is Revolt, a biochar-based supercapacitor made from Indonesia's abundant rice husk waste. It is fast-charging, low-cost, and sustainable, a climate-positive solution for energy and transport in the region.
Every year, Indonesia generates over 12 million tons of rice husk waste, most of which is openly burned. But what if we could turn this waste into wealth? By processing just half of this waste, we can extract 1.5 million tons of activated carbon, enough to power next-generation supercapacitors for urban energy storage. This process alone could help avoid 9 million tons of CO2 emissions, the equivalent of removing 2 million cars from our roads.
So why do we use biochar? Think of it like a sponge. It absorbs and releases water instantly. Biochar can do the same with electricity, making it ideal for fast-charging devices like supercapacitors. Being made from rice husk waste, biochar is porous, conductive, low cost, and carbon negative. It is a sustainable and local alternative to imported materials like lithium or graphene, perfect for fast, green energy storage like supercapacitors.
So, how does it work? First, we collect and clean the rice husk. We then use pyrolysis to create biochar at high temperatures. We activate this biochar, transforming it into porous high surface area carbon, ideal for electrodes. The activated carbon is then assembled with electrolytes and tightly packed to produce robust, low-cost supercapacitors. But why rice husk? Compared to commercial and exotic materials, rice husk activated carbon is not only high-performing and abundant, it's sustainable, affordable, and locally sourced in Southeast Asia. The results? A biochar supercapacitor that's both high value and climate positive. It offers three key advantages. First, high power density, delivering bursts of up to 10,000 watts per kilogram for applications such as EVs and grid balancing. Second, rapid charge and discharge, enabling 30-second fast charging for electric buses already employed in cities like Shanghai. And third, extreme cycle life, with over 10,000 cycles and a decade of shelf life. This is why supercapacitors are used in wind farms across China and Japan for their durability and ultra-low maintenance.
From 55 trillion rupiah opportunity, we aim to focus on the automotive energy ETLC market in Asia Pacific with 14.82 trillion of valuation. Realistically, we target 4 to 8 of market capture rate of 500 billion to 1 trillion for the serviceable obtainable market. In short, our business model costs come from OPEX, CAPEX, and COGS. This COGS will cost 182 farad in 100 farad model and 20% lower if the farad capacity is 400, which means our production will meet economies of scale. Finally, this allows us to set a competitive price of 25% price margin from the COGS. For example, we will sell our 400 farad model supercap at 200,000 rupiah. This price also 20% lower than the average. So we target high visibility, high demand market of two-wheeler fleets along with electric bus fleets and depot charging as secondary target market. Finally, our numbers shows that our net profit margin will reach 24% and break even in just 2.8 years. This will yield positive NPV of 1.7 billion rupiah, showing that our project is not only sustainable but highly profitable.